Hello students, welcome to my channel Maths Hub. So today I will be telling you about the beta and gamma functions. So in the last topic I told you about the gamma functions. So in this video I will be discussing about the beta function. Now we saw that gamma function was dependent only on one variable n. So we represented on the x and y axis and I showed you the graph also for gamma function. Now beta function, as the name suggests, beta, it is dependent on two variables, that is m and n, right? So the variables are not important. We can denote it by any variable. So suppose we have beta xy. So we know that when the function is dependent on two variables, it represents a surface in this form, right? So how do we define a beta function? So beta function is defined as beta m comma n is integration 0 to 1 x to the power m minus 1 1 minus x to the power n minus 1 dx, where these variables m and n, they are positive. M and n are greater than 0, right? Now this definition is very important because in all the results more or likely we are going to use this result, right? Use this definition. So let us convert. So let us try to convert this definition of beta function into another form which will be used in some of the derivations. So we have just done that beta m comma n is equal to 0 to 1 x to the power m minus 1 1 minus x to the power n minus 1 dx, right? Now let us put x is equal to sine square theta. So what will happen? What we will get? If x is sine square theta, then dx will become 2 sine theta into cos theta d theta. So beta mn becomes integration x becomes sine square theta to the power m minus 1. 1 minus x, 1 minus sine square theta will become cos square theta to the power n minus 1. And d theta will be changed, sorry, dx will be changed as 2 into sine theta cos theta into d theta, right? Now let us try to change the limits of integration. Now, when x is equal to 0, sine square theta is 0. So if sine square theta is 0, that means what value of sine will give me 0? When theta is equal to 0, right? So the lower limit of theta becomes 0. Similarly, if x is equal to 1, that means sine square theta is equal to 1. So that means sine theta is equal to 1. So which value of theta will give me sine theta equal to 1? When theta is equal to pi by 2. So we will get the upper limit of this integral as pi by 2, right? Now let us try to convert this. It will become 2 times 0 to pi by 2. Let us collect all the powers of sine. So here we have sine to the power 2m minus 2 and we have sine theta from here. So we will get sine to the power 2m minus 1 theta. Similarly, what is the power of cos? It will be 2n minus 1 theta. So this is the new definition of beta function in terms of sine and cos. We will write beta mn is equal to 2 times 0 to pi by 2 sine to the power 2m minus 1 theta cos to the power 2n minus 1 theta, right? So this is the alternate definition of beta function. So now from here, let us try to move to the properties of beta functions. The first property of beta function is the symmetric property. By symmetry, we means that if we change m to n, that means if the two variables are changed in their positions, they mean the same function, right? So there is no change in the answer. So how to do it? We start with the left side, that is beta m comma n. We did the first definition, it is 0 to 1, x to the power m minus 1, 1 minus x to the power n minus 1 dx. Now, very simple derivation. Let us put x is equal to 1 minus t. So what is dx? dx will become minus of dt. Let us convert this integral. X will become 1 minus t to the power m minus 1. 1 minus x. What will be 1 minus x? 1 minus x will be 1 minus 1 minus t. So it will be t only. So it will be t to the power n minus 1 and dx will become minus dt. Now, when x is 0, t will be 1. When x is 1, t will become 0. Right? Now, can we adjust this minus sign with the limits of integral? So it will become 0 to 1. T to the power n minus 1. 1 minus t to the power m minus 1 dt. Right? So what is this? If you compare it with the definition of beta function, it will become beta n comma m. Right? So from here we get that the positions are immaterial. Beta m comma n is always equal to beta n comma n. Clear? Okay. Let's move to the second property. The second property says 0 to pi by 2 sine p theta cos q theta d theta is 1 by 2 beta p plus 1 by 2 q plus 1 by 2 where both p and q are greater than minus 1. So how to prove this? Again, we use the second alternative definition of beta function. We define beta mn as 2 times 0 to pi by 2 sine to the power 2m minus 1 theta cos to the power 2n minus 1 theta d theta. Let us compare this sine and cos term with the sine and cos term given in the property. So what should you replace 2m minus 1 with? 2m minus 1 should be equal to put p and 2n minus 1 should be put it equal to q. So from here m comes out to be p plus 1 by 2 and n comes out to be q plus 1 by 2. Right? Let's replace it here in this alternative formula. So beta in place of m I'll get p plus 1 by 2. In place of n I will get q plus 1 by 2 is equal to 2 times 0 to pi by 2 sine to the power p theta d theta, sorry, sine to the power p theta and cos to the power q theta d. Right? So from here we get our result, that is 0 to pi by 2 sine to the power p theta cos to the power q theta d theta is equal to 1 by 2 beta p plus 1 by 2 q plus 1 by, right? Okay. So from here, let us do some special cases. In the same property, now we have the property, I'll rewrite the property here. 0 to pi by 2 sine p theta cos q theta is equal to 1 by 2 beta p plus 1 by 2 q plus 1 by 2. Right? So let us put q equal to 0. When I put q equal to 0, what happens? This integral will reduce to 0 to pi by 2 sine p theta d theta cos to the power 0 will become 1. So d theta will also come here. So this is equal to half b beta p plus 1 by 2 q I have put equal to 0. So I will get the term as 1 by, right? Similarly, you can also replace p equal to 0. So when I put p equal to 0, I will get 0 to pi by 2 cos to the power q theta d theta is equal to half beta 1 by 2 comma q plus 1 by 2. And since we have done the symmetry property, you can replace these terms. So this can also be written as half times beta q plus 1 by 2 comma 1 by, right? So this is the special case derived from property number 2. Next, let us move to third property, that is beta m comma n is equal to 0 to infinity x to the power n minus 1 1 plus x to the power m plus 1 dx. So how to prove this? So to prove this, let us start with the definition of beta function. Beta m comma n is 0 to 1, x to the power m minus 1, 1 minus x to the, x to the power m minus 1, 1 minus x to the power n minus 1 dx. Right? Let us put x as 1 upon 1 plus y. When I substitute this, what happens to dx term? Dx will be minus 1 upon 1 plus y whole square into dy, right? So now from here, what will happen? Let us substitute in this expression. So beta m comma n will become integration. X will become 1 upon 1 plus y to the power m minus 1. Let's see what is 1 minus x. 1 minus x will be 1 minus 1 upon 1 plus y. So it is 1 plus y minus 1 upon 1 plus y. So 1 and 1 cancels. It is y upon 1 plus y. So it will be y upon 1 plus y to the power n minus 1. And dx will be substituted as minus 1 upon 1 plus y whole square d. Right? Now what about the limits of integration? When x is 0, y will become infinity. When x is 1, what will y become? 0. You can just check this. When I put x as 0, what will happen? 1 upon 1 plus y will become 0. So you can revert it. Y plus 1 will become infinity. So y is equal to infinity. Similarly, when x is 1, 1 upon 1 plus y is equal to 1. So 1 plus y will be equal to 1. So y will become equal to 0. Right? Now, just calculate this whole term. This minus sign can be adjusted with the limits of integration and it will become 0 to infinity. In the numerator, there is one term y to the power n minus 1 divided by denominator. What is the total power of 1 plus y? M minus 1. We'll get m minus 1 plus n minus 1 plus 2. So this plus 2 minus 1 will get cancelled and you will get here m plus n dy, right? So the variable is not important, y variable. So this is what? This is beta times, yeah. So this is beta times beta mn is equal to this. So now I need m minus 1. So I know that beta mn is equal to beta n comma m. So I can also write that this is equal to beta n comma m. So I know that the variables m and n are do not matter. So I can change m to n and n to m. So I will get 0 to infinity x to the power m minus 1 divided by 1 plus x to the power m plus n d, right? So we know that by symmetry property, I can write it. Done? Okay. So now I start with the last property of beta function. That is beta m comma n is equal to beta m comma n plus 1 plus beta m plus 1 comma n. So we start with the right side. So it is beta m comma n plus 1 plus beta m plus 1 comma n. So if I go by the definition, beta m comma n plus 1 will be 0 to 1, x to the power n, 1 minus x to the power n plus 1 minus 1. Here it will be x minus 1, x to the power n minus 1, 1 minus x to the power n plus 1 minus 1 dx plus integration 0 to 1, x to the power m plus 1 minus 1, 1 minus x to the power n minus 1 dx. Right? Let us simplify this. This is 0 to 1, x to the power m minus 1, 1 minus x to the power, 1 and 1 cancels, we are only left with n, plus 0 to 1, x to the power, 1 and 1 cancels, we get x to the power m, 1 minus x to the power n minus 1 dx. Now we have two integrals, both the integral limits are same. So we can combine them and we can write 0 to 1, x power m minus 1, 1 minus x power n plus x power m, 1 minus x power n minus 1 dx. Right? Now in both the terms, what is common in them? We can take out common x to the power m minus 1 and 1 minus x to the power n minus 1. What is left in the first term? 1 minus x. In the second term, x is left. So now we can see that this x and plus x cancels. So what are we left with? We are left with 0 to 1, x to the power m minus 1, 1 minus x to the power n minus 1 dx. And what is it equal to? It is equal to beta m comma, right? So I hope you understood all these properties. So you can see that beta function is also emerging as a very nice mathematical toolkit, because some of the integrals you will find that we cannot solve it as such, but with these special functions, that is beta and gamma, we can solve it in very few seconds, right? So I hope you understood the questions, all the properties that I discussed. Still, if you have any doubt in anything, please ask me in the comment section. I will do reply. And the problems of beta and gamma functions we will be discussing once we are completed with all the properties of beta and gamma function, right? So if you like the video, do hit the like button and do subscribe my channel to get the latest updated video. So thank you so much and have a very nice day.